Good morning and welcome to our presentation. I'd like to start by giving a big thank you to the team at SAFE for their world tour, as well as the team at Spatial for organising today's event. I've got something a little bit different for you and an experience we've had working with our day-to-day data and some of the challenges that we've solved using FME. One of the hot button issues, particularly in the last couple of months with all the rains and floods, is land contamination, and maintaining accurate contamination records is an essential part of our data governance, as is the process of automating its management. So let's get into some automatic contamination. Just to introduce myself, my name is Michael. I'm working with Inner West Council, and I'm going to share a good story with you this morning. There's a little bit about me and FME. I've been working and using FME for around 8 years now. I've been a trainer for 3 years. I've been a certified professional for another 3. I feel like that's coming up to be renewed, so I might have to go and talk to our SAFE representative after this. Some of the projects that I've been involved in, including mapping national coverage for a large telecommunications group, automating some LEP alignments, and more recently a large data validation and harmonisation of land information systems. Let's get into it. So this is going to be our circuit for today. We're going to power on and cruise through a real example of how we solved several challenges using FME and give you some tips and learnings that can be applied to your automations and data management situations. As we go through, you might discover something that you can take away with you and resolve one of your challenges. Or if you have a solution to one of our challenges, let us know. We'll have a chat afterwards. Just before we get into it, I might get rid of my video just so that we can save some bandwidth. And I'll share something that I've found that will get us into the mindset. So this is an interesting statistic. According to an Oracle report at the end of 2020, they found that close to a third of a typical business manual task had been automated. These could be simple responses to an email, or it could be some image analysis, or it could even be building complex time series business analytic models. Now, I look at that and I say, well, there's got to be at least 70% of the business that we've still got to look at automating. And funnily enough, I think with FME, I can definitely see us improving that percentage. So let's talk about our one for today. For the immediate future, we're going to focus on 2 things: contamination and automation. Now, I told you this would be something different. We're going to tackle some of the important questions in the life of FME, such as where are we getting our information from? What do we need to do to make it usable? Who'll be the one doing the work? And how can we automate this cycle so we can leave it to run and trust that it will get the job done correctly every time? Now, since we're limited in our time together and there's more to learn about FME, I've done some of the research for us. There's a contaminated sites list published by the EPA on their website. So that's going to be our source data set for this. We can take addresses in our source data, filter them to our boundaries of our LGA, compare them against our database, and create an import file so that we can manage these in our day-to-day. Now, as you've already seen on the slide, there's a bit of a spoiler alert, but we're using FME to do the dirty work and also to clean up at the end. Now, once we've got the whole process together, we can automate this with a little bit of help from Task Scheduler. I mean, to me, it kind of sounds simple, right? wouldn't be any challenges at all in getting this done. Well, unfortunately, one of the big challenges we face as local council is maintaining an up-to-date repository of information that our residents can access. And this is made even trickier when creators and suppliers of this data are dynamic third parties. Now, as we're specifically talking about contamination, the Protection of the Environment Act 1991 requires local councils to maintain records for contaminated lands. In terms of coming from the supplier side, the EPA itself is responsible for assessing and determining if a piece of land is contaminated and if a contamination management plan is required. So we'll see a little bit of that later on. Having said that though, landowners can voluntarily submit their parcel of land for a contamination management plan. And the EPA and the landowner don't have to notify us in this case. This means that we need to refer to the EPA's master list of contaminated lands for any that have been voluntarily added them to the list. Now, the master list from the EPA is published in an uncertain monthly timeframe and may or may not be updated during that time, depending on the number and extent of contaminated sites that are identified. And this makes manual monitoring of the master list almost impossible. At the same time, from the customer side, the development and planning certificates provided by council require a determination of whether or not a land parcel is contaminated. I'm fairly certain with Sydney prices as they are, finding out your land is contaminated after purchasing it would probably be upsetting in the least. Lastly, there's also some council-specific challenges that need to be addressed, including some notation of existing separate local environment plans, the type of contamination, if there's already a contamination record in our database that's being upgraded, and lastly, to successfully complete this automation of our process, an import template needs to be created based on the database requirements. I'll talk more about that in a little bit. So with all of these challenges in mind, we're looking to set out to automate our contamination management. And the way to do that is with FME. So our target here is to have newly identified contaminated land records maintained in our database. As I mentioned earlier, FME is going to be our solution with a little bit of assistance from a task scheduler. And the result will hopefully be a happy customer. Now, before we break it all down for you and show you how we've done it, there are a few details to highlight. So this is what our source data from the EPA looks like. Luckily, they've been generous enough to provide an address, a latitude and longitude, which might come in handy a little bit later on. But this is what we're working with. I'd ask you to ignore the first address in that list. I suspect when they created this, it might have been 4:30 on a Friday, so we'll just let that slide. But what we need to do is take this contamination details, join them to our existing property records, and create a template that we can use for an automated import. Unfortunately, the template itself is defined by the database, so we must conform to their standard for importing. And this is what it looks like. We'll, again, talk about this in a little more detail later on, but this is our start and endpoints effectively. So with this in mind, going to jump into our workbench. So this is an overview of how we've done it. I'll go through a little bit more detail in a second, but first off, I just want to say I'm a massive fan of FME dark mode. If you haven't given it a go yet, I definitely recommend testing it out. I find that it looks pretty cool, and it's also easier to find what I'm looking for in our workbenches. Now, as I said, this is our solution as a whole, and we'll go through it in a bit more detail in the next couple of slides. But as just an overview, our workspace goes out to the web, draws down the contamination list that I mentioned from that EPA website. It then matches those contamination points against the cadaster. It also tags an ex-council reference. Again, we'll talk about that in a little bit. And then validates it against our existing database. Lastly, it updates some of the attributes and then constructs that template that I just showed you for import into the database. This then comes into our database and ends up looking something like this. So, as you can see, once our process completes, the contamination records appear attached to our land records. And this means that any of the requests regarding the property or land will contain that contamination flag. From our point of view, we can confirm that the contamination records have been applied correctly when we can see them appear in our corporate mapping application. They come up as these green squares. So that's the full picture. And let's get into the details and get into some FME. Now, in starting our workbench, we want to build that URL so that we can call the contamination list. And we've got it here on the left-hand side. This is the full URL. And I want to kind of break it down into some parts because we'll put that together as we go. So the first part I can see here at the beginning, fortunately enough, it looks like it's just going to be static string. So we can probably get away with just having that as the start of our URL. Happy days. The second part of the string here contains time and date information. In this case, we've got month and a year. It looks like that will probably update as we go because the month and year will definitely change. The last part of the string here is contains some format and hash values, which could make things a little bit interesting. So, as I said, what we want to do is effectively build our URL, and we're going to start an FME with virtually nothing. We're going to start with a creator. A creator is a great way to trigger Workbench when you don't have a reader to start reading with. In making our URL dynamic, we're going to add a date to our created object with our date time stamper. Because the date time is added in the year, month, day format, we can use a few substring extractors to pull out the parts that we want to use in our dynamic URL. Now, something I learned recently that's not necessarily FME directly related, but is that machines count from 0. So when we're pulling out our year from the string, just like we're doing here, our start index is going to be 0 because, as I said, our date time stamper stamps our year at the beginning, and our end index is going to be 3. So that'll pull out our year. And from there, we can work out month and day as well. Now, I'll say this a bit of back and forth and let you in on a little secret. Even though FME will be able to pick up month, year, day as it goes along, we ran into a little issue when first generating our request. In our haste to automate our side of the URL, we had FME picking up the changing month on the first day of the month, which is fantastic. Unfortunately, we were a bit too eager and didn't consider that the EPA team might need a few extra days to finalize their list for the months before they release it on the site. As such, we for the first couple of weeks of the second month, our deployed workbench failed because it was looking for an Excel file that didn't exist yet. So we had to add in a bit of leeway before FME switched over to the new month and update our months based on a bit of logic. We had our logic, we extracted the day number and applied a conditional value through an attribute manager. And I'll tell you what, this has taken what used to be a 3-4 transformer test and update process and does it all in one step. It's just magical. It looks like what you'd expect from an attribute manager, but it's flagged that there's possible values based on the tester within. Now, breaking it down from what we did, our logic here says that if it's less than day 16 of the month, then we subtract 1 from the month's number. Unless we're in January, in which case it then becomes the 12th month, and we'll also need to update the year. Otherwise, if everything's fine, it's the 16th or over, then we keep the same month number and maintain through our URL. So with that little bit of leeway built in, we now have our month and year numbers taken into account. What we can do is convert those month numbers to text and finally start building our URL. Now, the job of compiling our URL goes to the fantastic string concatenator, which has now got a very straightforward and easy process of taking all the hard work that we've done and building our string dynamically. Now, our screenshot gives it away here, but FME and probably the site as well allows us to get away without specifying the language or the hash value, probably very lucky for us, so that we don't have to figure this out each time. So we can leave that out. But now that we have our trusty URL built, we can call a website using a feature reader. The feature reader itself is something that's taken me a while to get my head around, and I'll probably learn more about them the longer that I use them. But we're using our feature reader here to do a read of a data set within the workflow itself. And in our example here, even though our read is of a data set on a web page, we aren't reading a web page format like HTML, CSS, or Java, but we're reading the Excel sheet itself. Now, that took me a while to get my head around when I was just starting out on my FME journey. So don't worry if that's something that didn't make sense to you. As you get more experience using the software, things will fall into place for you. But with our feature reader format set to Excel and using the URL that we just built for the data set, we now have a dynamic link to our source. In our case, it's the Excel sheet containing that contaminated sites that the EPA has been notified of. One amazing feature of the contamination list was the latitude and longitudes are included. And this means something very unique for our feature reader, in that when it reads the data set, it will automatically create those points and convert our table into a spatial layer, which, funnily enough, is very useful in our next stage. One thing that I will point out about the feature reader is that the default ports output spatial objects and schemas separately. This is very useful in dynamic translations, and we at the Council use this in several of our workbenches to update schemas when migrating data from one database to another. But in this instance, we get away with just getting the spatial data from our generic output, and we're going to use those in the next steps. So, as I said, now that we've got our contamination points, we can focus on moving to the next stage. And what we're going to do is look at selecting our cadastre objects that interact with our contamination points. We're going to do this with a spatial filter. This is done for a few reasons. To ensure we maintain only those records that are within our LGA, to retain our unique IDs, and also to set the stage for conflict detection later on in the workbench. As I said, we've fed our contamination points into the filter port of our spatial filter, as we only want to keep the cadastre objects themselves that intersect with our contamination points. Now, this step also ensures that we aren't processing more data than we need to by removing out the contamination points and also any cadastre objects that aren't contaminated. Our second spatial filter follows in a slightly different way. One of the not so secret parts of local government is that Inner West Council didn't actually exist until mergers 5 or 6 years ago. And hopefully one day before 2050, our planning team may finish up the combined Inner West LEP. But for the time being, we spatially need to tag our legacy LGA boundaries to determine which contamination type of the existing 3 we'll be using. So again, we're going to use a spatial filter, but we've reversed the filter and candidate imports here. So the filter is our LGA boundaries. Again, we've got the fun of maintaining 3 of them. And our candidate here is the land boundary objects that we just filtered out in the first step. These come in with their all-important land IDs and the flag of contamination as well. Now, as we want to maintain our land objects and just tag them with the XLGA name, we just want to merge the name from the filter in this instance. So we're making sure to check our merge attributes checkbox there. Once this is all set up and the correct attribute information is applied, we can move to our next stage, which is checking it against ourselves. So again, with the spatial all taken care of, we want to move on and ensure that the land objects that we flagged by the contamination points are firstly valid. But we also want to check that our records are current in our database as well. So what we're going to do is use a feature joiner in this instance. And we're going to check our land IDs that we've ensured to keep throughout our workflow against our entity IDs in our database. Now, this step ensures that FME doesn't let through any contamination records that already exist in our database and would create duplicates. So with all of that processing done, it's now time to start building that import template. And I know it was a long time ago, but we had a quick look at it before. Now, because we have a first line of static text in our template, then we have our column headers and then all of our row information. We've opted to build this file in 2 stages. To start with, we're going to use another creator to create a feature, as well as an attribute creator to add that specific text line to the first line of the template. All of this is going into a text line writer to create our CSV file. As I said, this creates our CSV file, which we're then going to populate with the rest of the information flowing through our workbench in a CSV writer. With the effective 2-stage CSV creation, the process is complete. Our import template is ready for processing. Now, as an important tip, when we're doing this, we made sure to manage the writer stages in the navigator by ensuring the text line writer is always above the CSV writer. This ensures that the CSV itself is created before the information can be populated from the CSV writer. It's also important to note that the feature type of the CSV writer must be named the same as the file created by the text line writer. Now, we have one last stage, and that's to automate this, so it can run without our interference. We're almost at the checkered flag. We just need to schedule this workbench so that all our hard work can come to fruition. Normally, we'd love to do this with an FME server. Unfortunately, we don't have that yet. So in our instance, we need to resort to running batch files through Task Scheduler. A simple batch file with a call of the FME executable and the path to your sparkling new workbench is all that's required. And once the task is set up in Task Scheduler, we've automated our solution. All of a sudden, that 31% becomes 32% that's been automated. And from my point of view, it sounds like it's lunchtime. Now, there are several tips and tricks that we've picked up along the way, and I wanted to share them with you because these may help your day-to-day FME skills. Our first tip is the Python kill command. Now, when we're running several workbenches or running FME, resource strain can be high, and this can cause workbenches to crash. We can reduce the strain on our system by closing any unnecessarily FME processes with just a few lines of Python, including the shutdown script. And we personally have found this very helpful. And if you're running into those issues, maybe give this a try. As I mentioned, we're working with batch files and Task Scheduler. So when we're working with batch files, there are several important things to keep in mind. Firstly, you've got to ensure that you have a license at the correct level available to run the workbench when you want the workbench to run. Otherwise, that could cause issues for you. Also, data sets that are being read and written will require a UNC path. As if you go to FME and say, yeah, you know, the data's on P drive, FME is going to tell you, well, I can't actually find P drive, so translation failed. One of the last points is to ensure that ensure the user you set up to run the task has permissions to read and write from all of the locations in your workbench. Now, I know there's a lot to remember. FME server doesn't have these issues, but once you get your head around it, it's relatively straightforward. Now, there's one thing that we found specifically in this instance that may be helpful, is when we were extracting our month and year from the date string, FME converts these details into text because we're using a substring extractor. However, when we're calculating the month adjustment, our text becomes a number. So January, which was 01, all of a sudden becomes just 1. That's something to keep in mind when we were mapping our text conversion over. But the difference between text and integers is important in FME. So just something to watch out for there. So with all of those, with all of our workbench complete, we finally have it. This is our result. This is what we've been working for. Our text file writer that creates the overall CSV and inserts the first row is there. The CSV writer has written in our column headings and all of the row information for us as well. And we've dropped all of this on a SAAS folder so that our database can pick this up and automatically import this. So it's time to take the checkered flag because we're done. The process maintaining our contamination records has been automated, and we can rest assured that FME is taking the job seriously while we move on to the next task. And maybe we'll see if we can automate those as well. Thank you very much. I believe we have some time for questions now.